Hello friends, welcome you all once again in lecture series Manufacturing Technology. I am AmitTiwari, Assistant Professor, Department of Mechanical Engineering, Suresh GyanVihar University, Jaipur. Today is the 26th lecture of this series and the topic of today's lecture is to punch and the types of punch. So let's start. The objective of today's lecture is to understand the principle of sheet metal being punch is sandwiched between the punch and die, and to understand the punch move downwards and it to the die. So basically this causes to the sheet metal underneath the punch to be sheared away from the surrounding metals. The outcome of this lecture is to understand the student will be able to understand about the punching is a forming process that uses a punch press to force a tool called a punch through the workpiece to create a hole via shearing. The punch often passes through the work into a die. A scraped slug from the hole is deposited into the die in the process. So basically today we are discussing about some punching process, and there are different types of punches are available for making the workpiece with a desired shape, and what are the application of punching with all this type of discussion in this today lecture. So the definition that we can say is a punch design. So punch design we can say the choice of the type of punch and its design depending on the shape and the size of the pressed or blanket counter and the work material. So for example, that is the large cutting parameters require larger the punches which are inherently rigid and can be mounted directly. So however, the smaller the die, all require the punches that may have to be supported during the operation, and therefore the need to be have the other mechanism to join it to the punch holder. So the punch can be broadly classified as the three types, that is a plan punch, pedestal punch, and punches mount in punch plate. So that is the basically application of the punch are to make it design very easily, or we can say that is a punches type of operation where to can shape or size is desired by the applying some pressure on the particular area of the sheet metal. So that's why the area will be covered, and having the press with that cutting the area with the requirement of this. So this type of working has been supported with the help of the we have to understand all the particular parameters. So therefore we need to have the other mechanism to join with punch holder. Just because we can say for example we are making a coin. So coin is also made by the punch. So it has some design specification. First of all, we mentioned that what are the diameter of that particular coin, and what are the thickness and circumference we will decide. And after that, what type of punch we design we have to mention on that coin. For this, all of the things we have to reminder during the punching. So that time we understand all this type of punch we are available. So the however the smaller the size hole and require the punches which may have to be supported basically during the operation. So and therefore the need to have the other mechanism to join it to be punch holder. Basically we are designed some punches plan, because punches plan is just if you want to make some small design with a sheet metal plate. With the help of this puncher we have to understand all the fundamentals which are to be understand very clearly by making the hole a small size of hole, and the different number of punches are available for this. So if you want to different type of punches are just on a single plant which we have to support it by the operation, because just we are doing the operation, and number of punches we required is depending upon the size of the diameter of the circumference, because the diameter is not having the easy to find defined, because we have a certain number of diagrams we have to design, and after it will be finalized that what type we are selecting for this, and having the number of quality will be uh, increasing. So that time we understand that punch and punch design basically, that is designing of the punches depending upon the what type of design you want to give by the laser cutting, or we can say that some by CNC milling, CNC lathe machine type you have used for the designing. So it depending upon the various condition, and what are the various spots we are having the making. So these are the some condition which we have fabricated, and it helps to be understand that punch are which are having the purported during the operation. So there are all the type of need to be, otherwise the mechanism we can say that to join it to be the punch holder. So punches are can be held broadly as to be classified. So the plain punch, basically we can say the plain area. The plain area covered by on the cutting on that metal sheet, and it has been removed by the easily, which to be easily by pedestal punches, or we can say that the punches mounted in the punch required for that, which have in the high, which have the high strength and high ductility we required for that to high, because we have want to the lightweight. If you want to make a composite material, that what type of material we have required, we just require for the lightweight material. So during the lightweight, you just to be observed that all this term we have to be supported. Therefore, the need to be have other mechanism to join it to be the punch holder. So that time the punch holder can be broadly classified for that. So the punch holder, it is not easy task. It will be difficult. But sometimes it will be required for that some special type of punch we design by the sheet metal forming with the help of the some machine. We have to open. We have to design the some tool that, but we have designed the some area by the CNC machine or any other type of specifications machine to design the circumference, to design the area. Just for example, I'm just saying that if you want to make a coin, some other coin that is for 10 rupees coin, or what, how you can manage? You can make by the punch. So you can number of coin be fabricated, and you can after that fabrication of the particular circumference or design for the what 10 number of how can write and about the thickness of 10 number, and that metal have to be finishing after that, after completely making. So these all are the some certain things we have to design, or for after that it will be used for the manufacturing. Then after the manufacturing we have to understand yes, it is some defects if we found, suppose the design which may not completely shown on that coin, and sometime that one portion that is up and head and tail portion are to be not completely mentioned. So this type of problem something will occur for during the operation, that we have to understand clearly. So that time the plan punch will be required. And the second one, the pedestal punch, is also the type of punch where you can understand some pedestal where you have to use some specific type of machine or equipment which we have to understand the parameters. Next one is the punches mounted in the punch plate. Punches mounted the punch plate, that is the number of punches are available on the plate of the surface. So that's why we have to fabricate with the help of the machining optimization. And this machining you have to be understand the process parameter to be required is to be a highly generated. This is highly generated with the help of this we have to design. At that time we have to clearly mention that the punches have to be highly motivated, and some type of designing pedestal we require. So that time of we have to understand for that. So these are some basic fundamental are the requirement of the punches. Punches is very popular because we have to make some special coins, and the small the business of the making the coil is to be large, and we know that the number of coils are required for one sheet. For example, if you make some small sheet and you can find out what the number of sheet, how much coins are covered in this sheet. So that is the multiple chip we use for that, and that time we mentioned that what type of parameter you have assumed. So this parameter to be considered as the pedestal punches or mounted punches, or we can say plain punches. So all this type of punches are to be understand with the effecting of a material have to be designed or to be executed for the sometime which we are not carrying supported by the mechanism. So there are a different type of mechanism we adopted for that. So for to joining, or we can say that the for blanking the counter, or we can say the cover material. So that time, for example, the large cutting parameters require the larger punches which are inherently give and get the mounted clearly directly. So however, the smaller the size hole require the punches which may have to be supported during the operation, and therefore the need to be have the other mechanism to join it to be punch holder. So that time we have to say that yes, the plain punches and the pedestal punches and have to be identified for the mechanism. So these all are the some basically punches design, the introduction of the punches design, and it is now very just a commonly popular type of technique which is adopted by you. It can also make the some student projects regarding to punch design, and have a very successful machining and optimization you can do it for to understand punching design, and some parameters requirement for which are to understand for making the coin or any other cellular section which are related to the small hole or the larger hole. So these are the same metal operation the punching design. Second is the plan punch. Plan punch we can say the by pair, and they are the simplest of all the types of pair. So by pair we can say that it is the simplest type of pair, and these are the made up of solid, which is these are made up of solid tool steel block and are directly mounted to the punch holder. So these punches are joined to be holder by means of dowels, screws in shown in figure, and this must be larger enough to provide the necessity or space for dowel and a screw, as well as the necessary strength to withstand the punching forces. So that time we can understand that some various the length and the various width of this punches should be the greater than the height of the punch. Sometimes it may be the become the more necessary to have the height of the punch greater than the either length or width, and this is the when the punch is extremely long and the work perform is not having or unbalanced. So these are some basically fundamental required for them. So these are the made of the solid tool steel block and directly mounted to be the punch holder. So that time we said that these punches are joined to the holder by meaning of a dowel and screws. So this meaning of the dowel and screws are related for this, and this type of material to be designed for providing the necessary spacing of the dowel, which have to be understood securely, which we are related for them. So to understand the punching forces, to understand the mechanism or design the made of a solid state, which are to be responsible for making the successfully covering of design. So that time we have to understand all the fundamental rights. The punching forces is not a simple task. First of all, to understand what is the basic plain task defined for this. So by pairing, by simplest of all the type of punches, there's simple punch. That means you want to make the small area of the hole, and you have to design that punch by the first of all computer wise, and that you want to analyze by the any software what type of forces act on it, and these forces are related to the are made up of easily or not, and these punches are to be joined with the help of the holder by meaning of dowels and screws. So these are some basically used for that. Have you an idea? This is using this in this diagram. So have you seen this diagram? These are the diagram that show that these are the sheet. These are the fine sheet. This is the length and this is the height. This is the length, height, and this is the width of the this sheet. And in this you have to apply the larger diameter punch and the small diameter punch. So that one we can say that the length is more larger and equal to the that we can say height, and the height and the length and the width of which all are the plain punch we have to design for like this. Because you have to apply for the smaller area and for the larger area, you have to design the punch for as per the requirement or as per the application of the material. So that time we have to understand this parameter. So that when these are the understanding of material which you have to be designed for that, which you are requirement for the material at the front of you. So this condition we have to use for the machining operation that we are to designing for that. So the requirement we can say that the requirement of having the good machinability or a good production which we have to be designed for the plant. So plant which we are using, it is the type of the technique which we are adopted. So plant punching, or we can say that the smaller the punching have been designed for them for the same material. So these are the some technically we are adopted for. So that time we understand the plant punches is very beneficial, and it has the capacity to understand the rolling. So the punching and the height, or we can say that the leveling to be designed for use. So the material having the we can say the material having the this is a triangle sheet. This is a sheet, and you can apply the sheet for the certain angle. This is some lining you are available, and there is a certain angle will be tilted from example 45 to 60 degree. That is the requirement as per the operation. So you just maintain the small, this is the larger diameter, so you can make the larger the whole type of punches, and if you want to the small diameter, you can make also the small type of punches which is available for the our condition, and at that time it will be operate. So that's why we can say that these are made up of the solid tool. That's why we are saying that these are made up of the some solid tool steel and a block, and are we can say directly mounted by the punch holder, and this punch are joining by to the holder by means of a dowel and screws, and this must be larger enough to providing the necessary spaces for the dowel and the screws, as well as the necessary strength required for that, and to understand the punching forces. So that's why we consider the length or width of the punch, these punches should be greater than the height of the punch, and at time sometime it may be become necessary to have the height of the punch greater than the either length or width. So this is why we can say that when the punch is excessively long and the work performed is not having the unbalance. So that time we have to understand this all the fundamental things to be required for that. At that time we have to have an idea generated which we are requiring for material, at which it is very possible for that. Yeah, it is just having the idea to be understand the diameter or circumference of area, what type of design you want to make, is a small diameter, larger diameter, and what type of shape your material be used for the shape. Because if you made the, for example, if you are using the aluminum, for example, if you made using the sheet of aluminum, then you know that the aluminum property is very light and easily to cut, and having the lighter material. But in case of, if you understand that the maximum strength, that is a steel or any cast iron, you have to select it for that, and these machines are not available for the machines and having the low strength. And how it is can be possible? You can do it. You can possible by the applying the some certain amount of operation with that. So these are the operation containing by this, and then the last, that is the pedestal punches. So what is the pedestal punches? The pedestal punches basically are known as also called the flag punches or shoulder the punches. So flag punches and shoulder the punches, we can say the pedestal punches are characterized by the larger the base surface compared to the cutting forces, and the flag portion, which is the integral portion of the punch, that we can say that the offer the excessively stability of the punch, and all the cutting forces exerted in the dissipated by the board base area, and thus pedestal punches are advantages for the heavier work. So that time we can say that also having the some diameter we are requiring for that some official excellent work we are producing with the help of all the cutting forces. So cutting forces exerted, that means the some cutting forces just apply like we can say on the surface of the we can say puncher and the surface of the workpiece. So that when the surface of the workpiece we required good strength which we have to be adopted for the machining surface. That's why we can say it is a very popular process, and also we can say the flank punches. So at the end, that is the punch is very popular and very good type of technique, and recently used for the material fabrication, or we can say that the material design by the help of some standardization for making the hole or any design with the help of you of some certain machine that with from the single point. If you're operating on a machine that is a single sheet you have to use. So what type of single sheet you do? You have to do for the flag proportion, which is an integral portion of the punch and shown in the figure. So offer the excellent stability to the punch. All the cutting forces exerted is dissipated by the rod base area, and thus the pedestal punches are advantages for the heavier head. And so this portion which have the integral portion of the punch, it is shown at the offer excellent stability onto the punches, and all the cutting forces exerted is dissipated by the board. So these are the one base area, and as the pedestal punches are advantages to the every other model they have to use for that. So these are the some tangentially we required for material. What are the strength having, and what are the functioning we are using for what type of requirement you have to do. So all this type of function you have to understand while doing the machining or pedestal type of punches that time. So that is the punching type we are deciding. Okay, so punching type deciding, that is a very commonly popular to understand the meaning that you can see in this diagram. This is a type of pedestal punches. So that time we have to you applying for this. For example, this is the I section rod, and you can apply this particular punches here for the top of the surface. This is a length, this is length, this is the width, and this is the height. So this is the height, this is the width, okay, and this is the length. So what we are doing? So we are doing the for cutting the operation. That the length is greater than or equal to the height, and weight is width is equal to greater than equal to the height. That the pedestal steering you want to make fabricate. So first of all, you design the AutoCAD section in AutoCAD design, and after that you have to fabricate the term which is related by this. These are the some small diagram which we have affected the material. So that type we have to understand properly what we are doing actually. So I hope you understand what are the basic features of for that. So the function that we had adopted is the type of material we used, and the functioning that the supporting area. You see the supporting area to punches are placed as the as mark on the top surface in equal direction and equal size and equal dimensions. So these are the some dimension accuracy will be providing for the punch. That's why we can say it is a very popular and very high standardization technique used for the making the hole and punches. Now you can see this is a diagram that is a pedestal punches construction by A, B and C are shown in figure. There are different type of diagrams are shown here. That is the first, that is you can see here a diagram that made by the, there are some different dimensions, and after that these are the pedestal construction are also made by the this type of direction, and that after this action. So these are the different dimension and different curve you provided by the pedestal punch, and it is a, we can say it is a simply is a very popular and having the height or having the very good accuracy will be provided by the punching machine. So that time the punching machine we can say it is a very popular for that. And the pedestal and the punching construction is now very helpful for the making the machining operation and making the design to be created for that sometime. So these all are the fundamental we required using for the machining, and has the pedestal type construction we generated. Just an idea, just this is a simple idea what we are doing basically. Okay. Now, second term, that is the punches mounted in punch plate. So punches mounted in placement, that is a punch plate is used generally to locate and hold the punch in position. So a punch plate is generally we use for the locate and hold in the punch in position. So there is a useful way of mounting, especially for the small punches, and there is are number of ways in which a punch is mounted in a punch plate. So the choice depending on the size of the puncher, and we can say that now it is a very number of ways we require for the number of which are the punch we have mounted on the punch. A plate, a simple method. It is a simple method of assembly. A simple method of assembly, a plain punch in the plate area, which we are covering the mechanism and to cross section area to be cut out, and with the help of fastening the punch by number of screw by number of making the holes on a particular punch itself. That's why we can say the punch plate has the necessary hole for locating the punch properly, and closely the hole are provided in the punch plate for the positioning of the squat or sharp concern punches. So these are some basically identified to be how it can be work, and it is easy to understand the punches mounted in the punch plate, and these are the some mechanism will be adopted. So are the some conditions and having the idea that we are using. So punch mechanism is that punching is the used for the generally to locate and hold the punching position, and there is a useful way of mounting. And that time we can say that especially for the small punches, there are the small number of ways and which are the punch are mounted in the plate punches. So that's why we can say implement in some implementation, and the choice is depending upon the size of the punch we required. And a simple method of assembly, a plain punches in the required. So that time the punch has the uniform cross sectional throughout the we can say it has been a plan, and the punches folder for the by meaning of the secretary. So that time the square root, or we can say the punches itself and the requirement has the necessary hole for the locating the punch properly. So that time we adopted all the type of currently situation. At the position we required, what are the position for this particular, we have to location it's decided first of all. So the locating the punch in properly. So if you do not have to understand the location of that particular with the equal size and equal dimension, then it will be mismatches basically. And this will mismatch. That's why the punching have not properly make a standardization design that we are not maintain. So we have to an idea that to understand how we can fabricate, how we can make the design properly. But first of all, you understand the location. What, for example, if you are if you have a 50 diameter or 50 diameter, you have a circle, and then what time if you have to make the five circle having the 10 mm. Okay, then it will be possible, but what location you can be decided. So how much gapping between them. So if you want to make an equal dimension or equal location from the top to side and the left to right, so you will be designed by itself with the punching plate and have the necessary hole. So for the locating the punch properly and carry the holes are provided in the necessary plate. So that's why we can say the position of the sharp or the sharp concern punch to be required for that. It is used for the same. Now these are some diagram design, some other design some standardization that we are using for that. So clearance the hole and provided in the punch or for the location or some position will be doing the advantages. These are the some concern, the specific concern basically. So you can see this diagram. That is mounting of a plan punch in a punch plate. That is, you can see these are the some plate. I'll place it as a metal sheet, and you can place the punch plate, and this punch plate having the some circle diameter. That is, you can see a plate for equal cross sectional area you have to use for that circle. And if you want to make this type of a punch, that is a number of you can see here the holes at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The total 10 if 10 or 12. So these are the equal and equal distance you want to cover here for this diagonal, or we can set this two distance between the two for holes. So you can see this is the radius and also different. Also same for the each and every hole. So that is r/2. That you can find out with the help of this. So the radius we can find out, or height we can calculate it by this, and 1/3 height of the h/3, that is denoted by. So mounting of a plan punch is a basically the punch plate are decided. So that's why we can say it is a very popular type of technique which we are adopted for nowadays in the machining operation. That's why we are selecting for that. So there are difference between the number of allocation and the difference between the radius of curvature we required, how much number of holes we designed for the particular punch, and how much dimension of the punch. So these all are the factors which we are affected to be material and have to be designed considered very properly. Because design is the most important. If you do not having the design, if you do not have the criteria to understand the fundamental, that we are not aware. So that the mounting of a plan and punching is a plan plate which we are affected to this. Punching is an idea, punching is a theory that we can apply for making the design of equal and a number of dimensions we are providing to that for making the holes. And the mounting of a plan and punch is a part of a mechanism which we are hold together. And this mechanism is to be used for that. And we can say that punch is a section. Punch is a mechanism which we are adopted to use. When we are applying for that, when we are using for that, we have to be an idea to how to be calculate for the material. So if you want to make a material, if you want to make a standardization, then you have to cut for the mechanism and give the dimension accuracies properly, the length and the breadth and the height you have to fabricate it, design by the software, and you can calculate by the first of all the dimension accuracy. So whenever you have to design the mounting a plan punch, the plan punch in that means the punch plate you have to select it for this, and you can apply the punches on the side of the four sides. You can force or extending by this. And if you apply the force certain, and this is a certain force we applied for the particular area, so you can observe that a compressive force will be applied, and that compressive force will be depending break the workpiece material. It actually depending upon the workpiece strength, the workpiece toughness, workpiece hardness. If the workpiece more hardness, and then it will be designed that it will be affected too much, and you have to design criteria. So we can say that the material having the strength and material having the cross sectional area to be designed mounted of a plan punches in having the related to this. So these all are the some fundamental we adopted to be understand the criteria of manufacturing of a punches. So these are the some basic structure, or I hope you understand this is a punching. Punching is a very popular, or we can say very easiest way to design any hole or section, or coin is the best example. If you know number of coins you have fabricated, or these are the best example for manufacturing the coins by the help of the punching, or any some cylinder. Or we can say that, for example, if you drink the Coca-Cola or any drinking bottle, that the cup, then the cap of that particular surrounding the cap is made by the punching also. So punching is also the different examples that you have. There are different so many examples of the punching. So that's why we can say that the punching is very useful for making the a cap of a bottle or any other type of instrument which we are using for that. So if you make the cap of the, for example, cold drink bottle, then how we can apply? How can apply? You just give the proper dimensioning. You have to select in the area of the bottle first of all, cap bottle area, and for designing with the help of this cap by the helping of the punching. So that's why we have to give a point at the how much curve radius of we are filleted we are providing, and we can also say that from how much amount of rotation of such a thing, number of threads have to be available, we provided. So these are the some fundamentals which we required to understand the basic principle of punching and punching design. Now this is another method, that is the molding methods of punch in a plate. In a punch in a plate, that is the step head and the bevel head. You can see in this diagram. This is a step head and this is a bevel head. As you can show, that is the difference between the length and difference between the thickness of the particular dimension also. So you can, if you want to step head, that is as a made up by this rectangular section equal in dimension both the side. And it is a D section. So if you want to make it at the B section, at the bevel side, so you can apply for the some corner area or corner, or we can say fillet will be required for the particular size and for the both sides for maintain the equality. So that's why we can say that even having the molding method of punches in a punch plate, these are the some diagram which we have fabricated, and these are the some sterilization to be used for the same. So that's why the material having the capacity and the punches plate are used for the frame material, and the capacity required for this. These are the some optimization technique which we are the designing technique, which basically we can say that by the AutoCAD software, AutoCAD or any other type of software you use for a design, and they just fabricate is designed by the helping of the punching software, punching machine, and the punching machine is depending size on the number of product, how much dimension you have, and how much sheet we required for making this such product, and the number of product if you wanted, and now the more number of sheet we required for making the design. So that all the type of understand the molding or punches we have an idea to be calculate, or we can step the machining. So that's why we can say that it is a very easy previous process. There is not any difficulty we face. There is no labor skill level be required. It can be operated for anyone. Once you have to doing the practical, and you will be easy to done. So these all are the basically fundamental you had adopted, and these are the some basic features which we are using for that. So that time we can say that the molding operation and the munching operation is used, and having the plain punch plating for this, and these are the some optimization technique we have to be used for the same. So that time the molding methods of punches are designed. And likewise, so I hope you understand that that's why we can say that to the statement. We can say the statement that is a punch floater type punches. Floater type punches, that means the punches whose cutting face diameter is less than 25 mm are termed as perforators. So the punches whose cutting face diameter is less than the 25 mm are termed as, you can say, perforator used, and punches need to not be rounded, but the inscripted circle of the punches should have the diameter less than the 25 mm. So as the rule, and as the perforator are mounted in the punch plate, the simplest and the most common perforator in the step head type of we shown in the figure, we can in the later slide we can say discussed. So mounted in a punch plate and by the meaning of the step head. So the proportional, or we can say the punches are to be standardization is used. So that I consider commercially available in the various sizes. So that's why we are deciding yes, it is a very simple. It is having the easy to fabricate or easy to design. That's with all the type of fundamentals we have to assumed. So the punches whose cutting face diameter is less than 25 mm, and the terms are from perforator. So the dimension is have a limitation. That way we do not increase in dimension. That is a 55 mm diameter we required. Less than that. So if you want to make a more than 25 mm diameter, then it is not required for design. So it has some dangerous or it not be fit for the sheet, or it not required for the puncture because the puncture has some specific diameter, that is the 25 mm below you use for that. So if the punching have the diameter and you have to use for that, we have to just create an idea that will all the actuators and the mounted in a punch having the plain idea that simply we consider the adopted the type of common perforator in the step head type shown, and we can say these are the munch mounted in the punch die punch plated by the mean of the step head, and the proportion of these punches are standardized or by the commonly the available in the various the size which are very popular in nowadays. Now we can see this diagram. These are the perforator punch. Perforator punch and they have some cross section that is A diagram and B diagram. We are shown in that method of mounting perforator punch in the punch plate. So if you want to make a perforator punch, you can see apply for this is a perforator punch, and this is the punch plate, and this is the backup plate. So actually these are the diameter. These are the not 25 mm mortar diameter. So you can keep in mind that if you want to make this section, it will be larger, and it having the dimension accuracy will be providing after perforator punch we have perforated. So that's why we can say that the material having the diameter, the material having design, which we are not easy to understand. Or we can say the perforator design that is intended by the material having the good scope, or the perforator we design for that. So that's why we can say that it is the responsible factor and the affecting area that we are perforator we use for the same. Sometimes it will be difficult, but having if you are doing continuously practice and on this machine, and you will be able to understand. So you can see this diagram how it can make this punch for that. So you can apply. First of all, you have to design for the this. You can take the sheet and just these are the popular punch. You can apply the punch here, and you can this type of circular will be punch are available. You can cut this section, and you can make the circular section from the sheet. So these are the diameter. These are the section which we adopted to mechanism. And these are the some adopted the principle and having the diameter. These are the some method to be used for that while adopting the machining. So that's why we can say that the punches, we can say that they're not the more than 25 mm diameter required for that. The punch whose center face diameter is less than 25 mm are termed as the perforator, and some diameter having the 25 mm as per the rule, and the operator are mounted in the punch plate, and the simplest, or we can say the most common reflector is the setup. So which are the some obtained by the different type of dimension and different type of diameter we use for the selector. So more the number of diameter, more the number of having the requirement which is to be used for the same. Or we can say that some punches we require for standardization and commercially available in various sizes. There are the different size of punches are available depending upon the area, depending upon the we can say that the dimension or as per the requirement first most of it. What are our requirement? What are our the main advancement we required for the improving the? So that's all. These are some unique technique or advanced technique to be performator type used for mentioning the plate, which were adopted. So that's why we can say these are some techniques we have to use for the same. Now, I hope you understand this all diagram, which is related to this. So the perforate the punches. So that is the design you have to fabricate. It will be easily to having the good manufacturer machining have used for this. Apply the punch with a certain forces and how much area to be covered by the single sheet, and the diameter for fabrication of the particular area by a circular coin you have to decide it by the requirement of a sheet also. Because the method is very popular, and having the making the coin caps of any drinking bottles or any type of this type of example we are using for the making the punch design. That's why it is a very commonly type of a technique we adopted. All through that we are using that rule have a profile mounted. That's why we can say. So once again, I'm repeating what is the profiter type punches. Basically, it is said that the punches whose cutting face diameter is less than 25 mm are termed as the profiter meter, and the punches need to be round, but the script circle of the punch should have a diameter less than 25 mm. And the rule of all the profilometer are mounted in a punch plate, and the simplest and the most common profilometer is the step head type shown in figure. So mounted in a punch plate by the meaning of the step head, and the professional of these punches are standardization by the commercial available and the various sizes. So these all are the some about the profilometer punches requirement for the same. Now at the end of this lecture, I am asking some questions regarding to the sheet metal operation of the punching. So the first question that arrives that is the following sheet metal operation includes both compression and tensile test in the part. The options are A. Blanking, B. Pressing, C. Drawing, and D is trimming. So the correct answer that is drawing. So we can say that the only in the sheet metal operation, drawing includes both the compression and the tensile forces, because drawing is the sheet metal operation which having the both stresses are acting on the part. That is the compressive strain and the shear strain that will be used for the same. Second question that is the following sheet metal operation includes only tensile stresses in the part. So the options are A. Stretch forming, B. coining, C. drawing, and D. trimming. So the correct answer that is A. The question that is the sheet metal operation. So the stretch forming includes only tensile stress in the part. So basically we're discussing about the drawing is the area where the tensile and compressing both are a part used for that sheet metal operation, and where the only tensile stress, that means the stretch forming operation in the sheet metal including only tensile stress in the part. So that's why we are saying that the material having the, if you're selecting in the sheet metal operation, the stretch forming operation we are using for the only tensile stresses act on that part, which is the use for the survival. Third is the spring back. Third question is spring back during the sheet metal operation is caused because of the options are A. release of the store energy during the elastic and plastic deformation, B. release of the store energy during the plastic deformation, third is the release of the store energy during the elastic deformation, and D is the excessive energy that was utilized during the forming processes. So the correct answer that is C. We can say that the spring back during the sheet metal operation is caused because of the release of the store energy during the elastic deformation. Fourth question that is we can say that the compared to brittle material, ductile material require force shearing operation. So the options are A. clearance based on material thinking only, B. lower clearance, C. higher clearance, and D. same clearance. So the options are that is correct answer that is high clearance. So we can say that the compared to brittle material and ductile material, so required for shearing operation, that is the higher clearance we required for that. So higher clearance ratio we require in between the brittle material and the ductile material if we are using the shearing operation for the between them. Fifth one is in a banking die to reduce the possibility of clumps clinging to the die. The following provision is made up of. Options are A. shear on the punch, B. shear on the die, C. angular clearance in the die, cutting length on the die. So the options are that is C. So we can say that completely blanking die to reduce the possibility of a slug clinging to die. The following provisions made up of angular clearance in the die. Sixth question, that is the find the correct statement below. The options are A is equal to clearance in the pressing die applied on the die, while in the blank die it is applied on the punch. Second B option is the clearance in the precision die applied on the punch, while in the blank die it is applied on the die. Third is the clearance in the pressing die applied on the die, while in the banking die it is the die applied on the die. So then last D is the clearance is the pressing die applied on the punch, while in the blanking die it is applied on the punch die. So the option that is B is used for the same. Seventh question, the only axisymmetric cup shape are produced by the processes. Options are blanking, B spinning, C deep drawing, and D shallow drawing. So the options are B deep drawing, same shipping drawing. Eighth question, that is bending process produces the following type of stresses in the part. Options are A tensile, B compressive, C tensile and compressive, and D shear. So the correct answer, that is C, tensile and compressive bending produce the following type of stresses in the part, that are both tensile and compressive. Ninth question, that is the following sheet metal manufacturing process do not experience any spring back. Options are A blanking, B shallow drawing, C deep drawing, and D stretch forming, that is D. So the correct answer, that is stretch forming, is the answer for the exam question. And the last question, that 10th, is the following sheet metal process require a large press. Options are embossing, B coining, C trimming, and D blanking. So the correct answer, that is B, coining, is the right answer for the question. So at the end of lecture, I am to recommend some books for understanding the lecture series of manufacturing technology. That is the Principle of Manufacturing Metal and Process by James and Campbell, Tata McGill Publisher. Manufacturing Technology by Foundry, Forming, Welding, M.J. Rao from Tata McGill Publisher. Production Engineering Science, that is P.C. Pandey by P.K.C. Casing, Standard Publication. And Manufacturing Technology by R.K. Rajput and Lovely Collection. And last, Manufacturing Technology by P.N. Rao by Tata McGill Publication. So if you doubt any query, you will be asked me on drop my email ID on amit.tiwari@mynet.com, and you will be contact me on my mobile number, that is 8690319448. I hope you enjoy this video. Thank you so much for listening patiently. Thank you so much.